Hello, we are going to have another lesson on advanced algebra. This is partial fraction, which is useful in A-level or STPM examination, and it has got a lot of application in different topics. Okay, let us go ahead and see what is this chapter. Now, okay, we are doing this partial fraction. I will explain what is the partial fraction here. Now you know that if you have, for example, 2 over x plus, suppose 3 over x minus 1, you can take the common denominator, which is x times x minus 1. Here you are going to get 2x minus 2 plus 3x. So you are having 5x minus 2 divided by x squared minus x. Okay, you have got these two fractions, you add them up, you are getting this one fraction here. Now, you have done it before. Now, what we are saying with partial, what we are learning in partial fraction, they are going to give these to us. Now we are having this, and having this, we are going to find these two. Therefore, what are the fractions which has been added up to get this fraction? We are going to find it out. Therefore, this is the reverse operation of what you have done before. Okay, now this is something which for you to understand what we are going to do. Now, I'm going to erase this from my board so that my board is clear, then I can do the partial fraction. There are 3 different cases in partial fraction. The case one is when the denominator can be factorized to the linear expression. Therefore, denominator are linear expressions. Okay, for example, I have 15 divided by x squared plus 3x minus 4. So there has been 2 different expressions added up, we got this one. Now we got this one. Now we are going to find that 2 expressions. First of all, we should be able to factorize the denominator. Let's see. Denominator is clearly can be factorized to x minus 1 times x plus 4. So I will assume that was a divided by x minus 1 plus b divided by x plus 4. Now I will take the common denominator here. So this will be x minus 1 times x plus 4. To make the denominator same, I have to multiply here and here by x plus 4. Therefore here I am getting a times x plus 4. And here I have to multiply by x minus 1. Okay, now since these and this one are equal and denominators are same, so that numerator should be same. Therefore, I'm going to get a times x plus 4 plus b times x minus 1 should be equal to 15. Now, here you have 2 methods to do it. One method is that you can expand this and put them actually equivalent, because for all the values of x, they are same. Okay? One method is that. That means now we can say ax plus bx, therefore a plus bx. There is no x the other side, therefore a plus b should be 0. And then you can say 4a minus b is equal to 15. So you can solve that 2 equation, get n. Here it's simple to do that, but if the number of the expression is more and you are getting quadratic equation, that method may be a little more difficult. Another method is substituting number. You can choose any number you want. that doesn't matter. If you choose any number, you are going to get the same answer because these two are equivalent. Therefore, the values of x is not important what value you are using. But if you don't choose a smart values, then you will have to solve a simultaneous equation, which will be sometimes difficult. How we can choose the smart values? You see that if I choose x equal to 1, this part will be 0. So b will vanish. I'm immediately going to get the value of a. So I will try that. Let's see. I choose x equal to 1, then that I will get a times 1 plus 4 is equal to 15. Therefore 5a is equal to 15, so that I can say a is equal to 3. Therefore you see, so fast I got the value of a. Therefore a is equal to 3. Now what is the other number which is smart to choose? The other number smart to choose is -4, because this will be 0 and this will vanish, a will vanish. Therefore I'm choosing x equal to -4. So this part is 0, therefore I'm going to get b times -4 -1 is equal to 15. Clearly from here this is -5, therefore b will be -3. If you remember, I told you a plus b should be equal to 0. You can see that a plus b is equal to 0. That is we are getting from the expansion. Okay, we got this. Let us do another example. It is not necessary to have two expressions here. It can be three expressions. Suppose we have x plus 1, then another example. Suppose x plus 1 divided by x times x minus 1 times x plus 2. So now here, because there are three linear, you look at this, the denominator, all of them are linear. Three linear expression in denominator, therefore the first case, easily I can do that. A divided by x plus b divided by x minus 1 plus c divided by x plus 2. You can see that I can take the common denominator. I can choose the common denominator. Then the common denominator will be x times x minus 1 times x plus 2. Therefore, here a is, to make the denominator same, x is present here in the denominator. Therefore, I have to multiply other two fractions. Therefore, these two I have to multiply, other two expression I have to multiply. Therefore, I am multiplying a by x minus 1 and x plus 2. When I am going to do b, therefore b, x minus 1 is there, therefore this is there, therefore x and x plus 2 will remain. Therefore x times x plus 2 and plus c, x plus 2 is there, then I have to multiply by, this is there, therefore x and x minus 1 is remaining, x times x minus 1. So again, same argument, because the denominators are same, therefore numerator should be same. Therefore x plus 1 is equivalent to a times of x minus 1 times x plus 2 plus b times of b times of x plus 2 plus c times of x minus 1. We can see that the other method, you have to multiply this. You see you are getting an x squared, therefore quadratic equation, and this will be more complicated. It's easy to substitute the number. Look at what are the nice numbers. The first number is x equal to 0. So if x is equal to 0, this and this will vanish, and then are going to directly get the value of a. Substitute x equal to 0. On the left hand side you are getting 1, on the right hand side you are getting a times minus 1 times 2, so that clearly a is equal to -1 over 2. If you are putting x equal to, no, the next number I am choosing, x is equal to 1. because this will be 0 and this also will be 0. So my life will be easy. X equal to 1. Then on the right hand side, on the left hand side, I'm going to get 1 plus 1, which is 2. Therefore, x equal to 1, a will vanish. Therefore, we are getting b times 1 plus 2. Then the last part also, this will be 0. Therefore, no need to write anything. From here, you can see that 3b is equal to 2. Therefore, b will be equal to 2 over 3. Now I will substitute x equal to, what's the last number should I substitute? Negative 2, because this and this will be 0, and then I'm going to get directly the value of c. If I put x equal to negative 2, then I'm going to get negative 1 is equal to c times negative 2 times negative 3. You can see that c is equal to negative 1 over 6. Okay, these are the values of a, b, and c. Therefore, your expression is x plus 1 divided by x times x plus 1 times x plus 2 is equal to negative 1 over 2 times over x plus 2 over 3 over x minus 1 plus negative 1 over 6 x plus 2. So I actually did the partial fraction for this expression. Now I will go for the second case. Case 2. In the denominator, you are having a perfect square. If you are having a perfect square, what should you do? Now, let's see. I will give an example. When I'm doing the example, I will explain what is the situation. Suppose 2x minus 3 is divided by x plus 1 square times x plus 2. Okay? Now, when I'm writing the partial fraction, you see, the most common situation is in the form of a number a divided by x plus 1 plus a number b divided by x plus 1 square and a number c divided by x plus 2. Now you can see that when you are doing this, you have a factor of x plus 1 and a factor of x plus 1 square. So the common denominator will be this. So you have to write a over x plus 1 and b over x plus 1 square and go on like that. Now, be careful because some of you are making a mistake here. Now, the common denominator is x plus 1 square times x plus 2. Here, the denominator is x plus 1. Therefore, one x plus 1 is there, the other x plus 1 is lagging. Therefore, a should be multiplied by x plus 1 times x plus 2. B. Because some of you are just looking at this, you are multiplying this by this, here by here, or here by here. Some method you are doing that. Don't do this type of thing. Just try to understand the mathematics and then do the mathematics. You are making denominator of this same as this. Therefore, what is lagging, one x plus 1 is not there, and x plus 2 also is not there. Therefore, you have to multiply by x plus 1 times x plus 2. Very simple and mathematically correct. Now here, what I have? X plus 1 square I have, therefore this I have, then x plus 2 is missing, therefore I will multiply by x plus 2 only. And the last part C, x plus 2 is there, therefore x plus 1 square I should multiply in the numerator, so that these two fractions are exactly the same. As we have discussed before, I can say that now denominators are same, so numerator should be same. Now 2x minus 3 is equal to a times x plus 1 times x plus 2 plus b times x plus 2 plus c times x plus 1 square. Now, let's go. If I put x equal to negative 1, this will be 0, this also will be 0, I am going to get the value of b. So I am going to do that. X equal to negative 1. Substitute x equal to negative 1. Then I am going to get, on the left hand side, I am going to get negative 2, negative 3. And on the right hand side, the first one is 0, the last one also is 0. Therefore, I am going to get b times negative 1 plus 2. So, from here, easily I can say b is equal to negative 5. Therefore, I got the value of b already. Now, if I substitute x equal to negative 2, x equal to negative 2, then on the left hand side, I am getting negative 4, negative 7. Then the first part, a coefficient of a will be 0, and then b also will be 0. Then I am going to get c times negative 2 plus 1 square, which is 1. Therefore, this will be only c. c is equal to negative 7. Now, what should I substitute there? Next. Now, you can see that there is no other number to make right hand side zeros. There is no factor there anymore. That's why I told you can choose any number you want. Therefore, you choose a nice number, either x equal to 1 or x equal to 0, something which is very convenient for you. My choice is always x equal to 0, because 0, working with 0 is very simple. Multiplication of everything goes to 0, then it will be alright. Therefore, I'm going to choose x equal to 0. But you can choose any other number. You can choose some other number yourself and see you are going to get the same answer. If x is equal to 0, the left hand side will be negative 3. The right hand side will be a times 1 times 2 is 2, plus b times again 2, and plus c times 1. Therefore, this is my expression. Now, I know b and c, I can find a. Negative 3 is equal to a, 2a. 2 times b. 2 times b is 2 times negative 5, which is negative 10, plus c is negative 7. You can see here you are getting negative 17, comes this side will be positive 17, 17 minus is 14, then 14a will be equal to 14 divided by 2 will be 7. Therefore, you can get a is equal to 7. Okay, we did this also. Now the third case is actually, I will go for another example, but I have to explain what is the third case. Case 3, if in the denominator you have a quadratic equation which cannot be factorized, okay, in that case what you are going to do? All right. Therefore, in the third case, denominator has a quadratic expression which cannot be factorized. Okay. Let us give an example of that. Suppose we want to see if we have a quadratic which doesn't have any factorization. Suppose we have got negative 2 divided by x cubed minus 1. Now, Some of you know how to factorize this, but if you don't know also, we know that it has got x minus 1, because if you are putting 1 here, it's clearly 0. Therefore, here we are getting a quadratic. We have discussed this thing in factor theorem and the division, long division, and this thing. We have discussed all of this. Therefore, here you're getting x squared. This minus 1 became again minus 1. Therefore, here is plus 1. And clearly you can check by the long division or by any method here. This is x. I'm not going to explain this. Okay, we have this one. Now I'm going to factorize to see what is the situation. Therefore, if it is like that, therefore there will be a divided by x minus 1. Here we should be very careful. Denominator, you are having x squared plus x plus 1, which cannot be factorized. You can see that if you multiply this a by this, when you are a common denominator, you are going to get x squared. But here there is no other x squared, so that here should be bx plus c. Remember, when there is in the denominator, there is a quadratic equation which cannot be factorized, then numerator should be in the form of linear expression, bx plus c. Okay? So it is always like that. So now you take the common denominator, you are going to get, denominator is x minus 1 times x squared plus x plus 1. This is a times of x squared plus x plus 1 plus x minus 1 times bx plus c. Now, again, same argument. Denominators are same, so the numerators should be same. Therefore, ax squared plus x plus b should plus x minus 1 times bx plus c should be equivalent to negative 2. Now you can expand this and then go for that method, which we have discussed before, but I am not going to do that. Oh, what I have written here, sorry, one mistake I have done. Silly mistake. I wrote b here. What is b here? It is the number 1. Okay. Now, the first thing I'm going to do, I am going to substitute x equal to 1, so I'm going to get the value of a. Therefore, if substitute x equal to 1, here I'm getting a, this is 1 plus 1 plus 1, this will be 0 is equal to negative 2, therefore a is equal to negative 2 over 3. Therefore, a we found. Now, how to find b and c? As I discussed before, you have to substitute numbers. As we discussed also, therefore x equal to 0 is the easiest number which I can do. Therefore, this will be 0, this will be 0, you are going to get a. This will be 0, you are going to get negative 1 here. This will be 0, you are going to get times c is negative 2. So, a is negative 2 over 3. Negative c is equal to negative 2. Therefore, you can say that c is equal to 2 minus 2 over 3, which is 6 minus 2. 6 minus 2 is 4. 4 over 3. Therefore, the value of c also we could find. Now, we want to substitute another number. I go for x equal to negative 1. X equal to negative 1. Okay. A will be times by 1 minus 1 plus 1 on the left hand side, plus negative 1 negative 1, negative b plus c is equal to negative 2. Now here will be a, negative 2 multiplied by that, negative 2 times negative b will be 2b, minus 2c should be negative 2. Now we have a and b, a and c we have, then we have to find b. Therefore, a is how much? A is negative 2 over 3, therefore negative 2 over 3. Sorry. Negative 2 over 3 plus 2b, which is unknown, minus 2c, minus 2 times of 4 over 3, should be negative 2. Now this is minus 8, this is minus 2, will be 10 over 3, negative 10 over 3, plus 2b is equal to negative 2. From here I can say 2b is equal to negative 2 plus 10 over 3. This is negative 6, therefore will be 4 over 3. Therefore, from here I can say b is equal to 2 over 3. Okay, this is, I think this became a long video also, and then you understood there are the different cases, 3 cases. The first case is the denominator, all of the factors are linear. The second situation is the denominator has a complete square. The third situation is when the denominator has a quadratic expression which cannot be factorized. Hopefully you have understood this nicely and you can do exercises on this. If you have any difficulties, please put in the comment. I will go and check and come back to you.